So this is number 1 from homework 16. It's an example of an application problem involving matrices and row reducing to get an answer. The other ones, you have 4 problems in this homework section. The other 3 all have either a video explanation or a written explanation. And so this is the one that didn't have an explanation to it. So I'm going to go ahead and make a video for it, just in case you have a question. You can kind of see how to work through it. So if you notice in the chart, it looks like a matrix already, kind of, right? You've got 3 rows and 3 columns. And so you're going to use that, and then you're going to augment it with the information given below. And so the manufacturer has 100.9 hours for painting, 55.2 hours for assembly, and 55 hours for packaging. So we're going to write our matrix. 1.6, 1.9, 2.6, so I got that directly from the chart. That's all dealing with painting, and so then I'm going to finish it off with the information for the painting, 100.9, as my solution column. Okay, and then I'm going to do the same thing with assembly. So I have 0.5, 1.5, 1.6, and 55.2 for the assembly row. And then the last row is going to go with the packaging. That's 0.9, 0.7, 1.5, and 55. All right, so there is my augmented matrix. It's going to be a lot easier if you have no decimals. So my suggestion would be to get rid of the decimals. Notice we only have a decimal represented to the 10ths place. So if I multiply each number by 10, I can get rid of the decimals. So that's what I'm going to do, multiply each element by 10. So multiplying by a scalar, that's fine. So that'll transform this matrix into 16, 19, 26, 1009, and then the second row will be 5, 15, 16, and 552, and then the third row is 9, 7, 15, and 550. All right, so we're going to try to use the Gauss-Jordan method to get this in reduced row echelon form so that we have 1s along the diagonal, 0s everywhere else in the coefficient matrix, and we'll be able to see our solutions for each of the following sets. So get the basic sets, the homeowner sets, and the pro sets per day. Okay, so let's use this matrix. First thing, get a 1 in position A11. So that means I'm going to divide everything by 16, or in other words, I'm going to multiply by 1/16. So 1/16 times row 1, replace row 1. So when you do that, divide everything by 16, you get 1, 19 over 16, 13 over 8, which is in reduced form, right? 26 over 16 will be 13 over 8, and then 1009 over 16. So if it doesn't go in evenly, go ahead and leave it in fraction form. The rest of the rows stay the same for now. Okay. Once you have a 1 in position A11, your next step is to get the numbers under that to be 0. So we want the 5 to become a 0, and we want the 9 to become a 0. So in order to get the 5 to be a 0, I'm going to multiply the row with a 1 in it by the opposite of what I'm trying to 0 out. So I'm going to multiply row 1 by -5, and then I'm going to add that product to row 2, so it'll 0 out, and then replace row 2. And then I'm going to do something similar in row 3. So for row 3, I want that 9 to be 0, so I'm going to multiply row 1 by a -9, add that to row 3, where I want the 0, and replace row 3. So I'm going to do both of those row operations at the same time, just to save a little space. So row 1, I'm not changing at this time. All right, so we're going to distribute that -5 through row 1, and then we're going to add that to row 2. So 1 times -5 is -5. -5 plus 5, so this is going to be -5, and -5 plus 5 is 0. We have 19 times -5 over 16. So that's going to be a -95 over 16 plus the 15. That will give us 145 over 16. Okay. Now we want to do 13 times -5 will give us -65 over 8. And then we're going to add that to the 16. And from that, we will get 63 over 8. And then we have 552. We've got to add that to -5 times 1009 over 16. So 1009 times -5 is -5045 over 16. And when we do 552 minus 5045 over 16, you will see that we get 3787 over 16. And so that's the transformation of row 2. And now in the same step, I'm going to go ahead and transform row 3 as well. So we're going to multiply row 1 by -9. So 1 times -9, you do this in green, is -9. 9 minus 9 is 0. 19 times -9 is -171 over 16. So 7 minus 171 over 16 is -59 over 16. 13 times -9 is -117 over 8. 15 minus 117 over 8 is going to give us 3/8. And then last we have 550, so we're going to do 1009 times -9 is -9081 over 16. And when we do 550 minus that fraction, 9081 over 16, you will see that we get -281 over 16. Okay, so now we've got the first column done. So the next goal is to try to get a 1 in position A22. So we want this 145 over 16 to become a 1. And so we do that by multiplying by the reciprocal. So we would do 16 over 145 times row 2 and replace row 2. All right, so let's see what we get when we do that. So right now I'm just replacing row 2. So row 1 stays the same. Okay, row 2, when I multiply through by 16 over 145, I will get 0, 1, 126 over 145, and 3787 over 145. Should have left myself more room here. Okay, and then the third row I'm not changing at this point, so we'll just copy it down. Okay. So now, once I have the 1 in position A22, my goal is to get a 0 above and below that 1. So this 19/16, I want that to be a 0. And this negative 59/16, I want that to be a 0. So let's see what I can do to make the 19/16 be a 0. So I want to multiply the row with a 1, that would be row 2, by the opposite of what I want to 0 out. So negative 19/16 times row 2, I'm going to add that to row 1 and replace row 1. Similarly, I'm going to do row 3 at the same time. So I'm going to multiply row 2 by the opposite, so that'd be a positive 59/16. Add it to the row I'm zeroing out this time, and then replacing that row. So let's see what we get when we do that. Okay, so the first row is going to be changing. So negative 19/16 times 0 is still 0. Add it to the top, we'll get 1. Negative 19/16 times 1 will be negative 19/16. Oops, let me get blue here. Negative 19/16. We add those together, we get 0. And then we have negative 19/16 times 126/145. And we get negative 1197/1160. And so then we're going to subtract those fractions. And you will see that you get 86/145. Okay. And then we have to do the last element. So 3787/145 times a negative 19/16. We get negative 71,953 over 2320. And so when we subtract those fractions, 1009/16 minus 71953 over 2320, we get 4647 over 145. The second row is not changing at this time, so we have 0, 1, 126 over 145, and 3787 over 145. And now let's go through and do what's in green, the row operations for the third row. So we're going to multiply the second row times the 59/16 and then add that to row 3. So row 2, 0 times anything is 0. So 0 plus 0 gives us 0. 59/16 times 1 is 59/16. And then when we add that to the negative 59/16, we will see that we get 0. And then 59/16 times 126 over 145. That gives us 3717 over 1160. And so then we need to add that to the 3/8, and we will get 519 over 145. All right, we got the last element. So 59/16 times 3787 over 145. We get 223,433 over 2320. So when we add that to the negative 281 over 16, we get 11,000. 11,418 over 145. Okay, so we've got the first two columns complete. Now we want to do the third column. In the third column, we want A33, which in this case is 519 over 145, to be a 1. And so we need to multiply by the reciprocal. So we're going to multiply by row 3 by the reciprocal, which is 145 over 519. So row 3 is getting multiplied by 145 over 519. And we're going to replace row 3 with what we find there. And so the first two rows do not change. So 1086 over 145 and 4647 over 145. Second row doesn't change. Third row, 0, 0. Multiplying by the reciprocal gives us a 1. And then we multiply 11,418 over 145 times 145 over 519. And we see that we get 22. Okay, so now we have a 1 in the position we want in column 3. So when A33 is a 1, we want everything above that to be a 0. So we want to 0 out the 86 over 145, and we want to 0 out the 126 over 145. And you can see, in fact, the third row you can already solve, right? The z variable is equal to 22. And I don't remember, I'll have to look at the top what the z variable was, but we're going to keep going until we get into reduced row echelon form. So let's 0 out what's in red and what's in blue. So to 0 out the 86 over 145, we're going to multiply row 3, that's the row that has the 1, times the opposite of what we want to 0 out, so negative 86 over 145. Add that to the row we want to 0 out, and replace that row. And again, in order to save space, I'm going to do the same thing for row 2. So I'm going to multiply row 3 now times the opposite of row of what I want to 0 out in row 2. So that's negative 126 over 145. Add that to the row I want to 0 out, that's row 2, and replace row 2 with that. Okay, so let's see what happens when we do those. That should give us our final solution here. All right, so we're not changing row 3, so I'm going to go ahead and write that in. Okay, let's look at row 1. So I have to multiply row 3 by the negative 86 over 145. So 0 times that is 0, so I'm going to add 0. 1 plus 0 is 1. 0 plus 0, 0. Remember, what you're doing here shouldn't impact the zeros and ones that you've previously gotten. 86 over 145. So 1 times a negative 86 over 145 is obviously negative 86 over 145. And when you add that to 86 over 145, you get a 1, not a 1, a 0. Those are opposites, you get 0. And then we're going to do 22 times negative 86 over 145. And we get negative 1892 over 145. And when we subtract those fractions, we get 19. So when we subtract those fractions and reduce, we get 19. And now I'm going to go through and do the same thing with row 2. So I'm going to multiply row 3 times negative 126 over 45. So anything times 0 is 0. 0 plus 0 is 0. Add 0 to 1, we get 1. Negative 126 over 145 times 1 is itself. When we add that to its opposite, we get 0. And then we have 22 times negative 126 over 145. And from that, we get a negative 2772 over 145. And when I subtract those two fractions, the 3787 over 145 minus the 2772 over 145, I will get 7. So your matrix now, the left portion or the coefficient matrix is an identity matrix now. So we have 1s along the diagonal, 0s everywhere else. And then we have our solutions 19, 7, and 22. So 19, 7, and 22. I'm going to go back up to the beginning. Okay. I'm going to have to erase all this from here. Okay, but we remember 19, 7, and 22. So I'm just going to write that here. We have 19, I guess I can write the whole matrix here. So you have 1, 0, 0, 0, 1, 0, 0, 0, 1, 19, 7, and 22. So the first row represented the painting, right? And so this is painting. The second row was assembly. The third row is packaging. And then we have columns. So the first column is the basic, the homeowners, and the third column was the pro. And so the 1 in the first A11 is in the position of basic and painting, right? So for basic sets, that's what the variable stands for, is the basic is 19. So X is basic. Y, the Y variable stands for homeowners, so homeowners is 7. Oops. And then in the third column, the pro column is represented by Z, and we found that Z is equal to 22. So for the pro, it's 22. So the manufacturer can produce 19 basic sets, 7 homeowner sets, and 22 pro sets per day.